Hi, my name is Cody. I'm a software engineer here in San Francisco. And in this video series, we are recreating Lovable using LangGraph. In the last videos, we've continued to build on our agent workflow, where basically we're chaining together a handful of prompts. And the last one that we added was this kind of intermediary step where when the LLM has decided that we are going to write code based on the message that the user sends in, it then sends it to the next step where it starts to do a design and a plan. From there, it takes that design and plan, the user message, and the current HTML page, and it passes it to our generate HTML prompt here. And now, even though this agent is not very complex, it is starting to get a little bit messier. So if we look at this actual code, we implemented this in a very just kind of straightforward way. You know, we're in a fast API application. There's a single route that our client hits. It goes through, it makes a determination to decide what the user intent is. The LLM will return with one of two options: respond naturally or write code. If it goes to respond naturally, it will send it to another prompt that is specified just for instructions to how to respond to the user. And if it decides to write code, it'll go to that two-step process that we just described. Now, all of that right now is only really represented in this source code file. And even though this isn't a complex agent, it can be nice to kind of visualize what it's doing to try and think about the agent architecture and how the agent is currently working. And right now, that's not really represented anywhere. And something that can actually help quite a bit is if we just take a step back and try to think about this at a high level and try to, maybe diagram this out a little bit. It can make everything a little bit more simple and straightforward. So let's go ahead and just do that really quick. First step we have is determine user intent. Okay. And what this is going to do is it's going to route this to two potential paths. It's going to get the intent from the user, so the large language model is going to actually make this decision of which way we're going to route it. If the user intent is respond naturally, then we're going to go ahead and respond to user. So let's go ahead and draw this out. We'll just do an arrow here, and we'll say this is respond naturally, right? And then we're going to go ahead and respond to user. And basically, one way you can think about kind of mapping this out is just thinking through what is the prompt, what prompt are we giving to the large language model at every single step of our application. So this first one, this first bubble, you can think of as the first prompt. It's going to determine the user intent. Or we have the prompt where it goes to respond to user. If this responds with respond naturally, then conditionally we will go to respond to user in that case. Else, if the user intent is to write code, let's go ahead and bring this other arrow here. This is going to be if we're going to write code. Then let's go ahead and look at what we do at that point. Then we do this design and planning prompt. Let's go ahead and write this down. Design and planning. Okay. And after design and planning, we are going to get the AI response plan and design. And then the next prompt is we're going to pass that in. The next prompt we pass into the large language model is our after planning generate HTML. And this is the prompt that actually generates the HTML code. So go ahead and draw an arrow to this. And this will be after planning generate HTML. And now this is just a little bit of a simpler, more intuitive way to think about our entire workflow so far. And I think it's good to just get a high level kind of conceptual understanding of exactly, what each prompt's role is, what the responsibility is of that prompt. And we can even just kind of project out into the future a little bit about what we're wanting to accomplish with our agent and our workflows. For example, right now we're just generating a single HTML page with this workflow, But in the future, we might want to generate more than just HTML. We might want to actually have a database that our large language model can create tables for and kind of work in tandem with the generate HTML prompt so that it can generate different views and tables and ways that it can format data that we might want to store that's being saved in a database. Or we might even want to have our agent have the ability to write Python code. Maybe this would be for things like adding user authentication or taking in third-party APIs such as Stripe, Twilio, or any other API integration that you can think about. And if that was the case, then this specific branch where we decide to write code would probably have even more potential sub-branches, right? So you might have one that's in this designing and planning node. It might not just go straight to the, generate HTML path. It could maybe go to a, generate SQL, right? To a generate SQL path. It could maybe go to a, like a Python, right? Some sort of Python backend code, etc. And I think it's good to just kind of think through, what this agent is going to turn into and what these workflows, how they'll continually kind of branch out. And let's just do a little bit of a gut check. What would happen to our code right now if we started to go down that path of implementing multiple branching points, where maybe at first they write code, and then maybe in this design planning prompt, maybe we would want to have the large language model not just respond with a high-level plan. Maybe we'll want to have it decide what the next step is, because it might not be writing HTML code right away. You might actually want to start with creating a database and database tables, and then maybe even writing Python code that connects to those database tables, and then implementing the HTML. So there's an order of operations here where it might not just jump straight into generating HTML, and maybe sometimes it wouldn't even need to write any HTML at all. Maybe we would just go straight to writing SQL directly. And when you start to think through some of these trade-offs and how this is all working, I think that you could appreciate that this current implementation might end up being just a little bit fragile. And what would we do if we wanted to actually loop back into ourself? For example, maybe we want to have a step where after the design and planning node, maybe we want to have a human or the user provide some level of feedback, right? Like maybe there's this step here where we want to have a human in the loop, right? Maybe this could say, give some feedback to the design plan and the requirements, such as, if it comes up with a game plan to write the game of Snake and the user, didn't want to implement a scoreboard, or if the user wanted to add some sort of extra functionality that maybe the initial large language model and design and planning left out, or maybe the design and planning node got confused and it didn't actually create a good game plan that was representative of the vision that the user had in mind for the application. Well, it would just go and run off and execute the code, and the user would never be able to actually provide that feedback, and it would be quite an annoying user experience for people that are building their application. So I point all of this out to set the stage for the problem that LangGraph actually solves. And the thing that LangGraph solves is one of the best ways to model these types of workflows, where rather than having just a very kind of naive sequential set of code that gets executed in this exact order every single time, it actually helps to think about things a little bit differently. And the way that LangGraph recommends is modeling your application as a graph. And that's why it's called LangGraph. And if you look at this drawing, we actually already have that. So a graph simply is just, you have these nodes, right? So you have these nodes, and then you have an edge that leads to another node, right? So this is maybe node B. Maybe this right here is node A, and this one is node B. And then you've got maybe edge 1. And one way that I like to think about these nodes is you can think of these as maybe, this is an individual prompt, right? This is one way you can think about it. An individual prompt or an individual LLM call. But you can actually have nodes that that aren't a prompt or LLM call at all. And so I think the official LangGraph documentation actually describes a node as a step of compute, right? And basically all that is meaning is it's just going off and doing something. So that means that this could also be something like a third-party API call. It could just, be reading data from a database. Or it could even be a type of tool call that the LLM can actually decide that it needs in order to make a decision on where it's going to route the control flow next. Another really common type of node is for routing the application. And if we go back to the LangGraph conceptual guide, then this is actually one of the main use cases and first use cases that most people start to implement when they're beginning to bring large language models into their applications and kind of introducing more agentic capabilities. Now, the LangChain team has a handful of really great videos about routing, and the way that we've implemented this right now is a pretty naive way, but it does get at the heart of the concept, where you basically just have the large language model make a decision of we're going to go either here or here or here or here, and then the large language model produces an output that then decides what the next step is. Now, the implementation that we have right now is very inflexible because, like we discussed earlier, it goes through and executes each command, and there's no way to have it route back up to another node. There's a great article that Lance and the LangChain team came out with recently about different kind of common workflows, and one of them is this evaluator optimizer loop, where you might have a generation, let's say, of a game plan to implement a 3D game of Snake with HTML and JavaScript, and rather than just immediately going to execute on that plan like we do in our current application, you could actually feed that back into another large language model call and have it basically critique the game plan that the previous large language model call had come up with. And it could actually provide feedback as well, and you could actually loop it right back into another, that same large language model prompt, and you could do it in a way where maybe it loops multiple times and it comes up with a really, really solid game plan. And you could even have it where you have an interrupt statement, and it raises the issue up to the human, to the user, and the user could provide feedback as well, and then you could run it through the generator again. This is a very common pattern with agents because we're trying to get something that threads the needle of reliability and consistency while keeping it nice and aligned with the user and grounded with what the user's actual intent is. If you think about the way that we would implement something like this in our current paradigm, how would you even do that? You would almost have to have a go-to statement, right? Or some sort of funny thing that are, traditionally in software development world, we don't like to use go-to statements, that kind of change the control flow of the application. Although, we could do that, but a more flexible way of doing that is actually just following along with this conception of having a node, an edge, and then having the control flow, meaning where the program will execute next, decided by the large language model. And this is exactly what LangGraph does. If we go back to our LangGraph concepts guide, it talks about how LLMs can pick their own control flow, and that's one definition of an agent. And if you look at this paragraph here, it gives us this degree of control by expressing the flow of an application as a set of nodes and edges. And that way, the control flow of the application can basically be set by a more traditional, program approach where you're doing something very similar where you have like an if statement and you have some output of the large language model and you kind of compare it and go that approach. So the benefit of pulling LangGraph into our application is not only that we'll be following a more intuitive and high-level implementation that we can reason about a little bit better, without having to look at the source code. But the other benefit is we actually unlock a very powerful new tool that LangChain has developed called LangGraph Studio. And what LangGraph Studio actually does is it gives you a visualization of your agent graph in real time. And it allows you to run this graph very, very quickly, to pause execution after certain steps, when you're exiting a node or entering a node. And it also allows you to do reruns and retries. Even after the workflow finished, you can basically go back in time, rewind it, and run the agent again. So now not only are we getting the observability benefit of using Langsmith to see each individual step broken out and to see the output from the large language model calls, but now we're getting a very powerful visualizing and debugging tool so that when things actually go wrong, we can go back in time, rerun the application from a very specific point in time, and we can even change the state before running it again, meaning that we can experiment quickly without having to make any code changes directly in LangGraph Studio. So in the next video, we're going to actually implement LangGraph and pull it into our project and do a very quick kind of refactoring of our project, and I'll show you how it cleans up the code while also unlocking the next tool that's going to allow us to build much faster, much more stable, and much more impressive application overall. Thanks, and I'll see you in the next video.